So now this is the OR gate and this is the OR gate behavior. OR gate behavior, kindly remember the OR gate behavior. This is very, very, very important. Hari, balanna. If you close one, it starts working. This one starts working. This one starts working. 2, no issue. It will use the shortest path, but still working. So let's turn on this, no harm. All 3, still it will work. Right? So likewise, it's working. But if you close all the switches, if you open all the switches ඔක්කොම වැඩ කරන්නේ නැත්නම් බල්බ් එක වැඩ කරන්නේ නැහැ. ඒක අපි මතක තියාගන්න ඕන. Right? Switches ඔක්කොම වැඩ කරන්නේ නැත්නම් බල්බ් එක වැඩ කරන්නේ නැහැ. We have to remember that behavior. So electrons and the battery view, right? If you close all the switches, it will work. 1 switch still work, 2 switches work, 0 switches, then it's not working. So that is the behavior. Okay, let's write down the behavior now. Right. Under that, please write, consider the switches, write the English note, right, as inputs, the switches as inputs, and bulb is the output. Working status of the switch, of a switch, is 1 and not working status is 0. Working status of the switch is 1 and not working status is 0. Bulb will not turn on. Bulb will not turn on. So this is the important thing. Bulb will not turn on if all inputs are 0. If all inputs are 0, all switches are not working. We can turn on the bulb even by turning on one switch. We can turn on the bulb even by turning on one switch, or even by turning on a single switch. Right. Based on this, we can say OR gate will output 0 if and only if all inputs are 0. OR gate will output 0 if and only if all inputs are 0. This is the important statement. So I'll explain why this is important, because so later when we are creating the complex switches, later when we want to create complex switches, so this logic is very important. We will use this logic when we want to create complex switches or complex circuits. We use this logic. Okay, once you're done, please let me know. If you finish writing, I can move to the next one. Finish writing this. So let's see the truth table as well as the symbol. So this is the truth table, right? Truth table for OR gate. Note that this is the important thing that we have discussed. If all inputs are 0, let's highlight inputs in yellow color. Then the output is 0. Let's highlight in green color. If all inputs are 0, let's put some, yes, background color would be better. And let's put the font color black. All inputs are 0, then the output is 0. Oh, cannot see the output. Let's make it black. If all inputs are 0, output 0. Otherwise, it's 1. Don't think about all 4 chances. Just remember one thing. Here also we did the same. අපි අර අනිත් ඔක්කොම අමතක කරලා එකයි මතක තියාගත්තේ. ඔක්කොම 1 නම් 1. ඒ තමයි n. ඔක්කොම 1 නම් 1. ඒ තමයි n. මෙතන හතරක් තිබ්බත් මේ හතරක් තිබ්බත් ඔක්කොම 1 නම් output එක 1. ඒ තමයි n ගේ හැටි. ඔක්කොම 1 නම් output එක 1. අනිත් ඒවා හිතන්නවත් එපා. වැඩක් නැහැ. අනිත් සියලුම අවස්ථාවල බින්දු ලොකු බින්දුවක් දාගත්තා නම් හරි. ඔක්කොම 1 නම් 1 ඒ තමයි n. ඔක්කොම 1 නම් 1 ඒ තමයි n. මෙතනත් එහෙමයි ඔක්කොම 1 නම් 1. ඒ වගේම O gate එක ඔක්කොම 0 නම් 0. If all are 0, O gate will output 0. All are 0, it's 0. Don't think about the other. If all are 0, this is 0. So you know how to find the number based on, now you can remember, no? How to find the combination based on number of inputs. What happens if it is 4? Okay, can you tell me if there are 4 inputs, can you tell me the circuits? 1 2 3 4 4 inputs. Right? A, you have 4 inputs, A, B, C and D. Symbol of OR gate is plus. A plus, B plus, C plus, D. That's how you symbolically represented OR gate. AND gate, it is dot. AND gate එක dot එකනේ තිබ්බේ. මේක අපි ලියන්නේ plus. Okay, can you complete the table quickly? Can you tell me the table? Input හතරක් තියෙනවා නම් combination කීයද පුතේ? You know that. If 4 inputs, how many combinations? Now we discussed. Then මේක පටන් ගන්නකොටම කතා කරේ ඒකේ. 4 inputs, how many combinations? Yes. Somehow.
16 combinations.
Yeah, 16 combinations. 32 රවින්දු ඔන්න ආයෙත් රන්වින්දු පටලවගෙන 32 නෙවෙයි නේද පුතේ? හතරක්නේ. හතර කියන්නේ දෙකේ හතරවෙනි බලය 2 to the power 4. මේ දෙකක් කියන්නේ 2 to the power 2 4. තුනක් කියන්නේ 2 to the power 3. ඒ හින්දා 8ක් ආවා. 1 2 3 4 5 6 7 8යි. 2 to the power 3. හතරක් නම් 2 to the power 4. It's 16. Then you have to write, how to write 16 combinations? It's easy. How to write 16? දාසය ලියන විදියක් මට කියන්න. There's a pattern. 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. Yes, this is how you write all 16 combinations. Then how to change the second one? Can anyone tell? See? See, yes?
00.
Yes, 0 0 1 1 0 0 1 1 0 0 1 1 and 0 0 1 1. That is the second. What is the third one? Yes?
4 zeros.
4 zeros. Again double. දෙකේ දෙගුණේ 4යි. 4 zeros, 4 ones, 4 ones. And 4 zeros, 4 ones. What is the first one? Yes?
8 zeros.
Zeros is 1 2 3 4 5 6 7 8 and then 1 2 3 4 5 6 7 8. This is how you write 16 combination. Easy. There's a pattern. So this is how, what we learned for number systems. Hexadecimal numbers, these are the first 15 numbers. These are the octal numbers, first 8 numbers. These are the base 4 numbers. Base 4 numbers you don't have in your syllabus, but base 4 numbers are there. This is base 8 octal. This is base 16 hexadecimal. Number systems walat meka tibba, logic gate walat meka tiya. Okay, output. Can you tell the output? It's very easy. What is the behavior of OR gate? We just write down, guys. Come on. Mukad OR gate ke behavior එක? Yes?
0.
Yes. Tell me the behavior. If all input 0.
One output is true, then the output is false.
Yes. If all are false, the output is false. Or you can tell here, this is the circuit that we discussed. හතරක් තිබ්බොත් මොකද වෙන්නේ? මේ වගේ input හතරක් තිබ්බොත් ඔන්න තියෙනවා හතරවෙනි එක. switches හතරක් මේ වගේ parallelly set කරලා තියෙනවා. ඒ වගේ තමයි OR gate එක. මේ එකකින් හරි ගියොත් බල්බ් එක පත්තු වෙනවා. හතරම බිඳුව නම් තමයි බිඳුව. That's the logic. All four are 0, then output is 0. Otherwise it's one, big one, 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 one. So no need to think about the others. It's one. But this is the important. If all are 0, it's 0. So kindly draw the truth table. Then we can finish discussing about OR gate. Kindly draw this truth table. Not just this one, right? So please draw all the 4 truth tables. This is truth table 1 for 2 inputs, 3 inputs, and 4 inputs. Please draw all 3. What is the symbol? Symbol of OR gate, it's like O. O, R is like half a moon or quarter moon, whatever, you can tell anything. So this is the symbol for OR gate. You can, so I have just input 3 inputs, but you can change the number of inputs. It can be 3, it can be 4, it can be 5. So it can be 2. This is the symbol. Kindly draw these 2. Symbol of the OR gate. And this is how you write A, O, B, O, C. A plus B plus C. We read as A, O, B, O, C. OR gate, it has the OR shape, O shape. But AND gate is clearly half circle. But when make a curve වෙලා තියෙනවා. OR gate එකේදී මේක curve වෙලා තියෙනවා. AND gate එකේදී මේක කෙලින්. Okay, let's see what is the next gate. That is NOT gate. That is NOT gate. Next gate is NOT gate. So please write down the third one. That is NOT gate. So it has only one input. Simple. It has only one input. It has one output. It has only one input and one output. It has only one input and one output. Okay, so what it does, it inverts the input. It inverts the input. So let's go and see the circuitry behavior. අපි ගිහිල්ලා බලමු circuit එක කොයි වගේ තියෙයිද. මේක හරියට ඔයාලගේ ගෙදර trip switch එක වගේ. Trip switch එකෙන් current එක ගියොත් ඒක off වෙනවා. Trip switch එකෙන් current එක ගියොත් off වෙනවා. කාට හරි current එක වැදුනොත් trip එක හරහා current එක trip වෙලා එතනින් off වෙනවා. ඒ වගේ තමයි. on මේකේ 1 ගියොත් 0 එන්නේ. 0 ගියොත් 1 එන්නේ. ඒක invert වෙනවා. අනිත් පැත්තට හැරෙනවා. හරි අපි බලමු කොහොමද මේක වෙන්නේ කියලා. Okay, let's go and draw a circuit for this. Then we can understand. Okay, so let's see. So I'm going to remove these switches now because I don't need this for anymore. Let me change the circuit. This one also not required. I can cut this. This a wire. I don't need this. Let's remove all these components. And so let's think you have something like this. Now your bulb is working. But what I'm going to do, I'm going to use another switch here. I'm going to connect this switch this way and this way. to this node, wait, to this node, and the next node, the second node, I'm going to connect this to this one. Now, if I close this, so but don't do this. You have to use a resistor for this, right? You have to use a resistor. Otherwise, battery will burn. මොකද short වෙනවනේ. Short වෙනකොට battery එක burn වෙන්න ඕන. එතකොට එහෙනම් මෙතන අපි use කරන්න ඕන ඇත්තටම resistor එකක් එක්ක. So let's use a resistor and then a wire. Okay. So not this way, for the other way you have to use resistor. Here also you have to use resistor, but here you can see. Now what will happen? Simply, if you turn on the switch, this electrons travel some other direction, so it will not turn on the bulb. Instead of, it will travel in other direction. This is like tripping. Simply, on switch will off the bulb, off switch will on the bulb, off switch will on the bulb. This is the behavior of that circuit. Okay, so let's draw this, and actually this is no need to draw the circuit, but you can write down this, what's happening in the gate. If you feed 0, it will output 1. If you feed 1, it will output 0. And this is the truth table for NOT gate. Quickly write this. So you write A naught as A dash. Some places it's there like A bar. මෙහෙමත් තියෙනවා සමහර තැන්වල A dash නැතුව A උඩින් line එකක් ගහලා A bar විදිහටත් තියෙනවා. That is also correct. I'll write both, right? A bar is also correct. A dash is also correct. Both methods are correct ways of writing this gate, not gate. Finish writing. If you have doubts, please ask, right? Don't wait. If you have doubts, please ask. Okay, after writing this, I'll give you a small question. Because you all are not talking, I'll give you a small question. At least try to work and try to solve this question. So I'll give a truth table. You have to draw a circuit for that. Okay, question. Draw a logic circuit. Draw a logic circuit for the following truth table. For the following truth table. Draw a logic circuit for the following truth table. Then this is my truth table. I have two inputs and the outputs. Two inputs and output. Very simple version. I have two inputs like this and the outputs. So A and B are my inputs. Sorry, A and B are my inputs, and this is my output. Output, actually, I'm not going to write the Boolean expression or something like this, A not for something like this. Can be 0, 0 and 0, 1. Then 1, 0. And the next one is 1, 1. And output will be something like this. I need you to draw a logic circuit for this. Can you draw a logic circuit for this? I'll give you 2 minutes. Okay, I'll give you 2 minutes. Quickly draw a logic circuit for this. If you have questions, any doubts, you can ask. ප්‍රශ්න තියෙනවා නම් අහන්න. මම දන්නවා මේක හිතලා කරන්න ඕන. මම කියලා දීලා නැහැ. කලින් කියලා දීලා නැහැ බය වෙන්න එපා අදාපු කට්ටියත් මම අනිත් අයට කියලා දීලා නැහැ කලින් I have not given this one but still you can solve හිතන්න පුළුවන්ද කියලායි බලන්න හිතන්න බැරි වෙන්නත් පුළුවන් it's okay it's totally okay හිතන්න බැරි වුණාට කමන්නේ අපි ඩිස්කස් කරමු මම විනාඩි දෙකක් දෙන්න මොකද හිතන කට්ටියට නැත්තම් අසාධාරණයි තනියෙන් හිතලා කරන්න පුළුවන්ද බලන්න usual method if AND gate was there if A and B both are 1 then A and B will be 1 that is the logic of AND gate no but here you have different A is 1 okay but B is 0 you expect 1 here how to get 1 AND gate need 1 here and 1 here that is the requirement AND gate win 1 here and 1 here but B is 0 then what you can do is you can use a NOT gate you can use NOT gate here right then what will happen if you use NOT gate here then what will happen NOT gate will invert this B NOT gate will invert this B to 1 therefore A and B not you will get it as 1 agree or not then B 0 වුණත් මොකද වෙන්නේ 0 වුණත් අවුලක් නැහැනේ not එක මොකද කරන්නේ යාව 1 කරනවා B 0 වුණොත් 0 1 කරනවා AND gate එකට 1 1 ආව නම් ඇතිනේ කොහෙන්ද 1 එන්නේ කියන එක වැඩක් නැහැනේ if AND gate get 1 and 1 from here it will output 1 understood hello තේරුණාද නැද්ද
Yes, sir.
okay
Yes, sir.
AND gate එකට එක එක කොහෙන්ද එන්නේ කියන එක වැඩක් නැහැ පුතේ එකේ දෙකක් ආවොත් එයා 1 දෙනවා ඒක එයාගේ හැටි එකේ දෙකක් ආව නම් 1 දෙනවා හැබැයි එකකුයි බිඳුවකුයි තමයි දෙන්නේ එකකුයි බිඳුවකුයි දුන්නට මේ දෙවනි බිඳුව not එකකින් එකක් කරලා දෙනවා ඉතින් n එකට මුලින් not එකක් හිටියා නම් අපේ වැඩේ සාර්ථක වෙනවා එහෙමනම් the solution for this is something like this okay so let's reduce the size of this this is what you need when 1 0 you need 1 therefore what you have done you have added a NOT gate then when it is 0 0 what will happen මේ අවස්ථා හතරම අපි ගන්න ඕනේ එකක් විතරක් අරගෙන බෑ 0 0 then this will become 0 this 0 will become 0 but this 0 will become 1 0 1 means for AND gate it's 0 0 1 ගියොත් n එකෙන් 0 මොකද n එකට දෙකම 1 වුණොත් තමයි 1 වෙන්නේ 0 1 ගියොත් 0 එහෙනම් a b දෙකම 0 වුණොත් මේක 0 next one 0 and 1 0 will anyway go as 0 1 will be inverted 1 will be inverted 1 will be inverted so it will also become 0 if double 0 it's 0 second time this one also it gets 0 then third one 1 0 this occurs 1 0 first one is 1 it will go second one is 0 it will invert so 1 and 1 it's 1 so this requirement is satisfied the fourth one both are 1 if both are 1 what will happen the first one will go as 1 the second one will be inverted it's 0 1 0 means for AND gate it's 0 so here using this kind of AND gate you can get output 1 only in one occurrence this occurrence only right so first draw the truth table I think you have already done that then draw all 4 occurrences that is very important all 4 occurrences avastha hatarama andinna why I am asking because it's really required to draw all 4 then only you know what will happen in each input right so this is first one 0 0 it's 0 the second one 0 1 again 0 then third one 1 0 1 0 then it's 1 then the fourth one 1 1 1 1 it's 0 this is how you draw a circuit no need to draw all 4 but just for your knowledge for the movement write all 4 හතරෙම තියෙන එකම තමයි with different inputs can you draw this quickly you have only 2 minutes to draw Within 2 minutes, this session will be over. Right? Kindly draw this quickly if you have not done. Okay, done. It's good. Ranvindo, I think better you draw all 4 because next, why I'm telling to draw all 4, I know you can draw 1. That is good. But the thing is, to understand the theory, it's better to have all 4. With 4 has 4 type of inputs, but the selected one is this one. That's why I'm asking to draw all 4 occurrences. Okay, after this, I'll add some homework, right? So please look at the Edmodo. Edmodo eකට මම homework ටිකක් දානවා දැන් මේකෙන්න. You have to practice this. I'll put some homework. Please do the homework, complete and update, upload it to your LMS. And I'll put some homework to your LMS, Learning Management System. Okay, I think you have finished. Right, please do the homework and come next time. If you miss the homework, it's okay, come to the class. But anyway, so try to do a homework and come because that's very important to practice this. Otherwise, you will forget the logic gate part. It's all about practicing. මේක කටපාඩම් කරන්න එපා. IT පාඩම් කරන්නම එපා. විභාගෙට. මම පාඩම් කරන්නෙම නැතුව ඔයාලට ඒකක් ගන්න විදිහ කියලා දෙන්න. පාඩම් කරන්නම එපා. පාඩම් කරලා අහු වෙන්නත් එපා. IT වල පාඩම් කරන්න දෙයක් නැහැ. You have to practice. After practicing, automatically you will get A pass. Only thing is practicing. Okay, then let's discuss the remaining part in the next day. Thank you very much for joining the session and good night and happy weekend.
Thank you, sir.
Okay, please finish
Thank you,
all
sir.
comments.